There's a limit to your love.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now moving on to formal charge. Formal charge of an atom indicates the gain or loss of electrons while forming covalent bonds. And so the way in which you assign formal charge is via this equation, where this is formal charge, this is the number of valence electrons, this is the number of non-bonding electrons, and this is the number of bonding electrons. So as you can see, you first have to determine the number of valence electrons of each bound atom, also count the number of bonding or shared electrons, as you can see right here, where each atom contributes one electron, and then you also have to count the lone pairs and compare with the number of valence electrons of the free atom, and you get the formal charge. So let's walk you through this. So formal charge that is equal to 0 is the most stable. This is important, so make sure you remember that. But an example would be the sulfate ion, SO4 2 minus. So first off, let's draw out what that might look like. S-O O, O. Draw all the lone pairs. And so what formal charge is really useful for is figuring out which is the more likely structure. So for example, this could be a potential sulfate ion with 2 minus right here, because now we know how to draw Lewis structures. But another way in which to draw this would be to have double bonds involved. We have double bond oxygen, double bond oxygen, and a single bonded oxygen. So a question could ask you, which is the more stable structure, since both of these have the charge of 2 minus, but one of them has 2 double bonds, the other has all single bonds. So first off, let's find the formal charge for oxygen, this guy right here. So for oxygen here, the valence electrons is 6, minus the number of non-bonding electrons, where you have 2, 4, 6, and you have the number of bonding electrons, and 1/2 of that. So since you have 2 bonding electrons, you have 1. And you end up with a value of -1. So the formal charge of all of these oxygens are -1. Now let's figure out what the formal charge for the sulfur is. So in this case, for sulfur, the number of valence electrons is 6. The number of non-bonding electrons is 0. And the number of bonded electrons is 2, 4, 6, 8 divided by 2. But remember, they're sharing the electrons, so you have 1, 2, 3, 4. So in this case, we have 4, which equals 2. So this sulfur has a charge of +2. So in this case, this molecule doesn't seem ideal because a formal charge of 0 is the most stable, and we have these negatively charged oxygens and a +2 for the sulfur. Now let's try this one. So for the single bonded oxygens, for the SO, we know that the formal charge for the oxygen is -1, so let's draw those in. But now what if you have this double bond? So now let's figure out the formal charge for the double bonded oxygen, which I'll indicate like so. So the number of valence electrons is the same, 6, minus the number of non-bonding electrons, which is 4 in this case, instead of the 6 before, since you only have these guys. And then the number of bonded electrons is 2. Since you have 4 electrons here, divided by 2 is 2. And you get a value of 0. So look at that. These two oxygens have have a formal charge of 0, which is the most stable conformation. And as you can see, that's because oxygen always wants to make 2 bonds with something in order to fulfill its octet. And so this oxygen is happier than this oxygen and thus more stable. And so now let's figure out what the formal charge is for the sulfur that's bound to the double bonded oxygen as well as the single bonded oxygen. So we have something like this. And so for this structure, we have 6 for the valence electrons. The number of non-bonding electrons is again 0. But now the number of bonding electrons is 1, 2, 3, 4, 5, 6. And again, you get a formal charge of 0. So lo and behold, this structure actually has a sulfur with a formal charge of 0, 2 oxygens with a formal charge of 0, and only 2 oxygens with a negative 1 formal charge. And thus, compared to this sulfur, this sulfate ion is more stable. So if the question asked you, which is the more likely structure, you would choose this one. So I'm going to draw a squiggly line around it to indicate that this is the more likely structure due to the formal charge that it experiences.
Like a map with no ocean.